last model that we're going to look at in this section is the logistical growth model, and we have a formula here. But even more important than the formula is the shape that this equation describes. And so typically what happens is when we have some exponential graph, it rises. But in real life, for example, with the coronavirus, the number of infections may rise rapidly in the beginning, but eventually it's going to come and level off and reach a certain value, which we sometimes call the limiting value. So this equation that we have here describes a population who have become sick with the flu T weeks after the initial outbreak. And so T is the amount of time in weeks, and the initial population is 30,000, which appears up in the numerator. And the first question is how many people become ill with the flu when the outbreak began. And at the initial time, we ask the question, what is T? Well, when the outbreak begins, we're going to say that T is equal to 0. So we will insert that into the equation, and then we have f of 0 is equal to the 30,000 divided by 1 plus 2 times e raised to the, and we have a constant there, but we don't really care what it is, because when t is equal to 0, e to the 0 is the expression, and that goes to 1, and so we get 30,000 divided by 1 plus 2, again remembering that e to the 0 is equal to 1. So the final answer comes out to be 10,000. The next question we're asked is how many people were ill by the end of the 4th week, and at this time we can say then that t is equal to 4 because t is the time in weeks, so we will plug that into the equation. So we'll get then that f of 4 is equal to our same 30,000, but divided by 1 plus 2 e to the, now this time the constant is important, I've got negative 1.5, and the time t is 4, so we'll multiply here, and we end up with 30,000 divided by 1 plus, I'm going to do this calculation first, and it comes out to be 0.00495. And simplifying completely, we end up with 29,852. Now, when we think about this in terms of the total population of the town, nearly everybody in the town has gotten sick with the flu. We certainly hope that doesn't happen with the coronavirus, but that is the nature of the logistical function. Its limit is going to occur when you encompass the entire population. So the question is, what is the limiting size of f of t, the population that becomes ill? Well, it can't be any more than 30,000 because that's all the people there are. And again, hopefully we're not going to be going quite in that direction.